Precipitation Reactions, Section 7.6. Now we're going to start talking about chemical reactions and the ability to predict whether or not a reaction will occur. For example, if we have potassium iodide and sodium chloride, both in aqueous solution, these AQ means aqueous solution, they're both dissolved in water, and we mix them together, we get no reaction. We do not see any product formed. So what we're going to be able to do by the time we finish this lesson is predict whether a precipitation reaction will form. So precipitation reactions do not always occur when mixing two aqueous solutions. When a potassium iodide solution is mixed with sodium chloride, no solid forms, which means no reaction occurs. So basically what we're saying is that no product forms that is insoluble in water. Therefore, you have to make sure that you remember your solubility rules. Potassium iodide and sodium chloride, no reaction. So when you take these two and you mix them together, you get potassium ions, you get sodium ions, you get iodide ions, and you get chloride ions. The sodium came with the chlorine and it could form sodium iodide, but sodium iodide is also an insoluble product. Potassium could form potassium chloride, but potassium chloride is also an insoluble product, so there is no reaction when these two reactants are mixed together. Let's look at a reaction where a precipitate is formed. If we have potassium iodide and lead nitrate, so here we have potassium iodide going into a solution of lead nitrate, and we see this beautiful yellow precipitate forming. So what we have here is lead iodide forming, and we have aqueous lead nitrate. And what we're about to see is that these two compounds are made up of ions that swap partners. So the potassium and the nitrate stay in solution. So potassium came with iodide, but it goes with nitrate and stays in solution. Lead came with nitrate, but when it gets in solution and sees iodide, it can form a soluble lead iodide species. So it forms a solid, which drops out of solution, leaving the potassium nitrate or the potassium nitrate in solution. This is a mistake where it says lead nitrate aqueous. It's supposed to say potassium nitrate. This is a picture in your book. So for this problem, I just realized that this should actually be KNO3. So KNO3 aqueous. Okay, and lead iodide solid because it's potassium nitrate and lead iodide. So you should realize that this picture from your book is incorrect. So predicting precipitation reactions. The key to predicting precipitation reactions is understanding that only insoluble compounds form precipitates. In a precipitation reaction, two solutions containing soluble compounds are combined and an insoluble compound precipitates. You must know your solubility rules to be able to do these problems. Okay, so if we have potassium iodide, for example, so here is a beaker representing, in a cartoon form of course, potassium iodide dissolved in water, and lead nitrate, so here we have nitrate ions and lead ions dissolved in water, lead nitrate. If we mix these two together, then we have our lead ions, our nitrate ions, our potassium ions, and our iodide ions. Now when we mix these together, lead can have access to iodide, and it does, and it forms a precipitate. In the beaker, you'll see a precipitate form. It's that beautiful yellow color you saw in the last slide. Nitrate and potassium are what are called spectators. Okay, so they're just hanging out in solution. They're spectator ions, spectators. Okay, the instant the solutions are mixed, all 4 ions are present. If 2 of the ions can combine to form an insoluble species, then a precipitate forms. The ions which remain in solution are called spectator ions. In this case, it's potassium and nitrate. Okay, so again, the same reaction we wrote. We write, let me get my pen. Okay, potassium iodide plus potassium nitrate gives lead iodide, solid, and potassium nitrate, aqueous in solution. Notice we had to balance it with a 2 for potassium nitrate and a 2 in front of the potassium iodide. So what you do is you take your 2 reactants and you swap them. See if they swapped partners, would you make a solid? And yes, this would be a solid because we know that lead iodide is a solid species. This would be aqueous, but the reaction will go to the right. The reaction will happen because this precipitate forms. This precipitate. Sometimes you'll see precipitate PPT, precipitate. Okay, will the following reaction produce an insoluble product, or will the reaction occur? Okay, so here we have sodium carbonate. Let me get my pen. We have sodium carbonate and copper chloride. So if we swapped these partners, can we possibly form a insoluble product? So here we have copper carbonate and sodium chloride. So sodium carbonate is aqueous and copper chloride is aqueous. When we mix them together, we do form this copper carbonate, which is a solid based on our solubility rules. Now you have to know your solubility rules or you'll never know whether a reaction is going to occur. Carbonates are usually insoluble except for some exceptions. So copper carbonate solid forms. And so we get copper carbonate solid and sodium chloride aqueous. Who are the spectators here? The spectators are sodium and chlorine. Those are our two spectator ions, and we'll get more into what spectator ions are in the next section. But just the ones that are still hanging out in solution, because sodium chloride is not an insoluble salt. It's soluble in water, so those are spectator ions. Okay, will the following reaction produce an insoluble product? Sodium nitrate and copper chloride. And we'll see how this does not produce an insoluble nitrate and an insoluble product. So here we have sodium nitrate and copper chloride. Now, we want to know if sodium can go with this anion to make a solid, or if copper can go with this anion to make a solid. And it can't, because sodium nitrate and copper chloride are both insoluble salts. So no reaction occurs. We have no reaction. Okay, so the key to predicting precipitation reactions is understanding that only insoluble compounds form precipitates. In a precipitation reaction, 2 solutions containing soluble compounds combine and an insoluble compound precipitates. Will a precipitate form when solutions of lithium nitrate and sodium sulfate are mixed? So first thing we want to do is write the formulas of the two compounds being mixed as reactants in a chemical equation. So lithium nitrate is aqueous, sodium sulfate is aqueous. Remember, you must be able to write formulas for compounds. Okay? Below the equation, write the formulas of the potentially insoluble products that could form from the reactants. So if we get our pen and we decide if these swapped partners, if lithium went with sulfate and sodium went with nitrate, would a product form? Okay, potentially insoluble products, lithium nitrate, lithium sulfate and sodium nitrate. Use the solubility rules to determine whether any of the potential new products are indeed insoluble. Sodium nitrate is soluble, lithium sulfate is soluble, so no reaction is going to occur. We do not form a soluble precipitate when we swap partners. These are your suggested problems that you need to do in your textbook. I highly suggest you do them. What I'm going to do for your quiz is I'm going to look at the blue problems in the back of the book.